Hello dear students, I Abhinav welcome you all in resultant, and in this session guys we will be dealing with RCC practice sessions. Let me again tell you guys, in this game changer series already we have completed SOM. If you have not seen, you can see after this session we have completed soil, we have completed hydrology, and now we are going with RCC. What is this game changer series? This series is dedicatedly for the GATE aspirants, and we will be taking those questions from we will be taking questions from those topics from where the maximum times the questions will be asked. Some of the questions will be PYQ, some of the questions will be other than PYQ, and lot of MSQ questions will be there. If you have not subscribed to our channel guys, please subscribe soon so that any of such sessions that we are taking in this channel should not be missed by any civil engineer guys. Those who are watching me for the first time, let me introduce. Hello. Yeah, audio is coming. Those who are watching me first time, let me introduce myself. My name is Abhinav Sir, having 13 plus years of teaching experience, done my MTech from IIT Delhi, got All India rank 164 in 2012. You can join my Telegram group. Already guys, more than 6,000 students have joined this for all the important updates, civil engineering content, and any doubt, you can't join me in this Telegram link. Okay, this Telegram group, that is Civil by Abhinav Sir. For GATE 2026, our batch has been started. You can join the resultant. You have to download the resultant app from the Play Store, and then you can join us here. Let me mute the volume here. Yeah. Okay, for 2025 students, the crash course is going on. You can join the crash course guys, all the 2025 students. And if you want to connect me guys, let me be little here. Now I guess you can see the number. This is my number. You can directly connect me, and this is my mail ID abhinav@resultant.in. Okay. In our courses, either for 25, 26, we have live plus recorded classes, study notes for every subject, PYQ for every subject, workbook which includes lot of MSQ, MCQ, NAT for every subject, formula book for every subject. These study notes now for every subject, formula book for every subject, and study notes, formula book, PYQ, and the complete workbook. This you can download also for the lifetime. Okay, so you can download the resultant civil app and join us here. So how's the Josh? Hi Chiru, good evening. Hi Abhas. Okay, not for UPPSC but for GATE we have. Okay, let us go with the first question. This is MSQ. Okay, so more than one options may be correct. What this is saying, for avoiding the limit state of collapse, the safety of RC structure is checked for appropriate combination of dead load, imposed load and live load, wind load and earthquake load. Which of the following combinations have to be considered? What are the combinations that can be there? Yes guys, come on. Tell me on the comment section. Oh, mobile gir gaya bhai. Chalo. Which of the following combinations are possible? Come on. Guys, see, if you see the code, then in the code these are the combinations. Okay, they are asking for limit state of collapse. That means we have to see these values. So it can be 1.5 dead load into, when dead load and dead load and imposed load we are considering, it can be 1.5 times of dead load plus 1 times of live load. Okay, imposed load means live load. So 1.5 of both is possible, not of wind load. No. Wind load is not possible. Sorry, 1.5 of dead load plus 1.5 of wind load. Is this possible? Yeah. In this case, it is possible. 1.5 of dead load and 1.5 of wind load. This is possible. 0.9 of dead load and 1.5 of wind load. Is this possible? 0.9 of dead load here and 1.5 of wind load. That is also possible. 1.5 of all. 1.5 of all. No, there is no 1.5 of 1.5. Only these two, not all. So this is not possible. 1.5 of dead load, 1.2 of imposed load means live load, plus 1.2 of wind load. Yes, this is possible in this case. So A, B, de Villers will be the answer. A, B, de Villers will be the answer. Arvind, Single Saab, this is MSQ. Namaste. Guys, please like and share the session with everybody so that maximum students can join our session. Guys. Everyone on the comment section, come on everyone. Hit the question hard. Any doubt in this? If not, I am going forward now. If not, let's go further. This is question number 2. This has been asked in GATE 2008. in 1 mark. GATE 2008 in 1 mark. A reinforced concrete structure has to be constructed along a sea coast. What is the minimum grade of concrete as per IS 456 is to 2000? Minimum grade of concrete for the sea water. Tell me everyone. Come on. Come on. Minimum grade of concrete for sea water. Chalo bye. Minimum grade of concrete, guys. The answer can be M20. You always remembering M30. Okay, answer can be M20, can be M30 also. Both carries the minimum grade. When it is about plain concrete means without reinforcement, then it is M20. When it is about the reinforced concrete, that means with the reinforcement is M30. They have asked about reinforced concrete, so answer will be M30. But guys, before such questions, I have seen many students have just remembered it is M20. Oh, sorry, M30. Please check. Might be next time the question is asked of plain concrete, the answer will be M20. This has been happened for mechanical students in strength of materials earlier. What was that? They asked, what is the range of mu? Okay, so one time they have remembered 0 to 0.5, 0 to 0.5, 0 to 0.5, 0 to 0.5. Next time the same question, but the answer was -1 to 0.5 for Poisson ratio. Because earlier question was different, now the question was different. Earlier question was for metals. For metals, the Poisson ratio is from 0 to 0.5. But for all materials, next time the word is used for all substances in this word. That time the answer will be -1 to 0.5, because human tissues and soap polymers can have mu negative. So guys, please don't make up of your mind that you will be having some fixed answer. Okay. Let us move to the next question. This again MSQ. Come on. What are the assumptions for the limit state of design, limit state of collapse in flexure, guys? Come on, everyone. Come on, I guess it is visible now. Plane section before bending. Let me be here so that you can see. Plane section before bending remains plane after bending. That is only why strain diagram is linear. Okay, the maximum strain in the concrete in the outermost fiber is 0.0035. Yes, maximum strain in the steel from the offset method. Okay, from the offset method we get this value na. From the offset method, from 0.002 strain that you study in strength of material also. This 0.87 is nothing, guys. It is the partial safety factor for steel, that is 1.15. So partial safety factor, it will be 0.87 Fy. So this is also correct. Relationship between compressive stress distribution in concrete and strain in concrete may be assumed to be rectangular, trapezoidal, parabolic, or any other shape which results in prediction of strength in substance. Yes, any shape can be assumed, okay, but result should be agreed. So answer will be A, B, de Villiers, not A, B, de Villiers here. It will be A, B, C, D. 2008 2-mark question. Please do it. Everyone on the comment section, hit the question hard. Guys, what they have given? They have given the unfactored. Unfactor means they have not used any safety factor here. Okay. And for the beam, the movements are 50, 80, 120, 180 for dead load, live load, wind load, and earthquake load. What should be the design movement as per the IS code? What will be the design movement as per IS code, guys? Come on. Just I have shown you the table, guys. I have shown you the table just before couple of questions. From the same, you have to do it. Now, what is the dead load movement? 50. Live load, it is 80. Wind load, it is 120. GATE 2008 2-mark question, and earthquake load is 180. So the case 1, there are various tables na. Yeah, these tables, various tables na. So one by one we will be taking all of them. When case 1, that is dead load and live load only I am taking. This one, dead load and live load. So 1.5 of both. So 1.5 of 50 plus 1.5 of 80, that means 1.5 of 130, that will be 130 plus 65, it will be 195. Case 2, when these are the values, so for the maximum we will be taking 1.5 of dead load, 1.5 of dead load plus 1.5 of what is written here, wind load and earthquake load, whichever is minimum, whichever is maximum. So 1.5 of 50 and 1.5 of wind load we will be taking, or earthquake, we will be taking earthquake na, because it is maximum. So 180 plus 50 is 230, 230 into 1.5 is 345. Now case 3, 1.2 of all, so 1.2 of dead load, 1.5 of live load and 1.5 of wind load and earthquake, whatever is maximum, because we assume that earthquake and wind both will not be coming same time. Earthquake and wind both will not be coming same time. So this will be how much? Sorry, that is 1.2 I guess. 1.2, 1.2, 1.2. This value is coming 372. Okay, and we maximum of 195, 345 and 372. Is 372 na? Is 372 na? Yes, Ayushman, good evening. Rotela Saab, how are you? Come on, come on, come on everyone. Give me yes or no. Let me be little side so you can see me. Let me be little side so you can see me. Come on guys. Any doubt? Any doubt? Please let me know. Okay, let's move to the next question now. MSQ question. MSQ question guys. Come on. Which of the following cases are considered for safe design of reinforced concrete members? Safe design. Over reinforced is not safe, yeah. That will show you the brittle failure. That will show you the brittle failure. Over reinforced is never safe. It is either the primary compression failure, primary, first should be the tension na. First should be the tension. So it will be under reinforced section. So first failure should be tension and then the compression will be coming. So it will be B comma D. Got it everyone? B comma D. We should be designing for under reinforced section na, because under reinforced means steel less. So first steel will be failing. Steel will give you the warning because it is a ductile failure. And secondary the compression should be coming. Secondary the compression should be coming. Civil engineer Ehsan Saab, it is both. It is MSQ question. It is MSQ question guys. Come on, come on, come on everyone. Come on. Got it? Shall we move ahead? Okay. 2009 1 mark question. The modulus of rupture, not the modulus of elasticity. Not the modulus of elasticity guys. Modulus of rupture. Okay. What will be the modulus of rupture as per the IS code? As per the IS code, what is the modulus of rupture guys? Come on. Tell me please. Tell me please. Come on, come on, come on, come on, come on. It is 0.7 under root FCK. Okay. If sometimes they ask the clause also, then it is IS 456 is to 2000. That is in the clause 6.2.3.2. Okay. For limit state of collapse, the partial safety factor recommended by the code for the concrete and steel. What are the partial safety factor for concrete and steel respectively? What are the partial safety factor for concrete and steel respectively? Come on please. Come on. Give me the answer. Okay, for concrete it is 1.5. Can you anyone tell me on the comment section why less value? Why less value for steel and more for concrete? Why less for steel Why less factor of safety for steel and more for concrete? Why less for steel and more for concrete? Because guys, steel is more homogeneous. Steel is more homogeneous. Generally made in factory, not generally, always made in factories. Okay, where the every mixing temperature, everything is perfect or near about perfect. But concrete, sometimes your the laborers are making in the site itself, so it is not as homogeneous as steel. So variation can be more. Therefore, more factor of safety for concrete. Thank you, soundtrack. But these are not the low students, guys. Okay, you can see other channels, it is even lesser than this. Okay, MSQ. Tell me. Flexure shear failures occurs under large bending moment and less shear force. No, flexure shear failure occurs only in case of when there is bending moment, no shear force, not less, but it should be no. Results in flexure cap which are at 90 degree with horizontal. Yes. Guys, suppose this is a simply supported beam. You have seen the cracks like this. Here it is 90 degree and at the end it is 45 degree. Why? Because at the center there is only bending moment and shear force is 0. Shear force at the center is 0, only bending moment. So bending moment produces, if you take an element from the center, let me take a green element here. So only the this will be coming bending stresses, whatever m suppose here is m1. So m1 upon I into y. So when something is like this, okay, so cracks will be like this, 90 degree. At the support, why it is 45 degree here? Because at support bending moment is 0 and its shear is there. So it is producing at support, the shear block will be like this, pure shear stress. And in pure shear stress, the maximum principal stresses are at 45 degree. Okay, when you draw the Mohr circle for pure shear stress, so maximum principal stress here is 90 degree. So in real life it will be 45 degree. So maximum stress will be, principal stresses will be at 45 degree like this. So when something is steering like this, so crack will be like this, at 45 degree. So this is flexure crack is due to bending. And yes, this is also correct. It occurs when the shear span to effective depth ratio is more than 2.5. Okay, when shear strength to this is more than 2.5, this is there. Have you understood, guys, the logic? Have you understood the logic? Everyone, please tell me. Please tell me, come on. Everyone. Okay. Great. Okay, excellent question. One of the finest question that has been asked by the GATE examination in RCC subject. This was asked in 2005 in 2-mark question. What they have asked to you, that we generally do what? Stress strain curve, how we are making? Like this, and straight line, it is a parabolic here. They say that suppose the curve is not like this. We are not assuming the curve like this, but we are assuming to be curve to be straight line, and then again a constant straight line after the 0.67 FCK. In this case, what will be the depth of neutral axis from the compression fiber? In this case, what will be the depth of neutral axis from the compression fiber? They are asking this case. Let me make quickly a new slide for this to explain you in a better way that now the formulas of the earlier one you cannot take. The earlier formulas of finding the neutral axis you cannot take. Those formulas you cannot take. 0.36 FCK into B into XU is equal to 0.87 into Fy into AST. Those formulas you cannot take now. Okay? The simple reason why you cannot take those formulas, because those formulas are when the stress was initially parabolic. Happy Christmas handbook, how are you? Now, suppose your section is like this. Here is AST, this is B, this is suppose neutral axis, and XU is asked from the top fiber. The depth of neutral axis from the compression fiber is asked. Strain diagram is always linear. Nobody can deny this. Either it is working stress method, either it is limit state method. Strain diagram is always linear because there is an assumption that plane section before bending remains plane after bending. So how the strain is going? 0.0035 and 0.002. 0.0035 and somewhere here it is 0.002. So stress diagram now if I make from 0.0 to 0.002, the stress is straight. From 0 to 0.22 it is straight, and after 0.22 to 0.0035 it is straight line like this. What is that straight line? 0.67 FCK. Okay, and here the stress will be of stress of steel, that is 0.87 Fy into AST. Okay, stress, this is force here. Stress will be only, stress is Fy, but we take safety factor na, Fy by Fy divided by 1.15, that is 0.87 Fy. Now guys, if I go further ahead of this, suppose I take this as X, or let this taking be alpha and this be XU. So from similar triangle, not this alpha, if I am taking this suppose A, B, C. So AB by AC from similar triangle is 0.002 upon 0.0035, AB by AC. So from here AB by AC you are getting as 4 by 7, and AB plus AC is XU. So this is first equation, this is second equation. Two equations, AB by AC is this and AB plus AC is XU. From here what you will be getting, AB is 4 by 7 of XU and BC is remaining, that is 3 by 7 of XU, correct? AB is from these two equations 1 and 2, you will be getting this AB and BC value. What is the total compressive force? What is the total compressive force? Compressive force is stress into area. So what is the stress in CB region? First of all let us do, yes, first of all for CB region. For this region, force is stress into area, so stress is constant 0.67 FCK. What is the area? Area of BC is 3 by 7 XU into B. So this is the area. This is the area 3 by 7 XU into B, and this is the stress 0.67 FCK. Give me yes or no. For the bottom area, again what is the force stress into area? So what is the area of this? Area of this is AB that is 4 by 7 XU into B, and stress here is something else, that is 0, and here it is 0.67 FCK. So area into stress, but stress is different at every point. Here it is 0, then more, then 0.6 FCK. So since it is linearly varying, so I can take the average. So from here the CT value you are getting as 0.48 FCK into B into XU, and compression should be equal to tension. So 0.48 FCK into B into XU is 0.87 Fy into AST. Let me write it here. 0.48 FCK into B into XU is equal to 0.87 Fy into AST. So 0.48, what is FCK? What is FCK? M20. What is B? 300 into XU is equal to 0.87. Fy is how much? 415. AST is Fe 415, 16 mm dia, 3 bars. So 3 into pi by 4 into d square. From here the XU value you are getting as 76 mm. Yes or no? Yes or no? Yes, good Arvind. Good Arvind. So XU got. Now what is the second question? The depth of the neutral axis obtained from the previous and IS 456 differs by how much? If I go for IS 456, we will be doing this 0.36 FCK into B into XU is equal to 0.87 Fy into AST. From this formula, you will be getting the XU value as 100.82 or approximately 101. So difference will be 101 minus previous was 76. So what is the difference? 25 mm, that is C. Give me yes or no, please. Give me yes or no, please. Everyone. Everyone. Okay. Now, if this is asked in 2006 for 1 mark, if the characteristic strength of concrete FCK is defined as the strength below which not more than 50%, not 5%, not 5%, usual value is not 5% of the test Q fails, but it is 50% of the test values are expected to fall. What is the FCK? Guys, usually you study that M20 is the grade of concrete when if you make 100 cubes, then more than 95% cube will be having a strength more than that. But here they are saying 50%. So if it is 50%, then it will be the mean value, na? Yes, Vinay, good. If it is 50%, then it is the mean value, na? If it is 50%, then it is the mean value, na? Got it or not? Take this as a homework, guys. Excellent question, guys. Excellent of a question. Guys, when the failure will be? Failure will be in 3 cases. Case A, when load fails, load is more than the permissible value, or not load, load is fine, but the stress will be coming, or stress is more than the strength, or you can say the failure is maybe due to the excess load. Okay. Strength is less of material, load is fine, but strength is less. What we expect from that, the strength is strength is less. This is what we expect, the load is more. This is what we expect of material, the strength is less, or both. Load is more than what we expected, and strength is less than what we expected. What is the chances of strength failure? 5%. 5% na? Because 95% of the cubes are having more strength than the FCK. Only 5% of cubes are less strength na? Similarly, the chances of load more than is 5%. So failure will be when load fails but material does not fail. First case. Plus the probability will be when load doesn't fail, that is 0.95, 95% chances load doesn't fail, but material fails, failing of material is 0.05, 5%. And next case is when both fails, material also and load also. The failure of material is 5% because 5% of the cubes are having lesser strength than FCK. Material failure is also 5%. We expect that 95% chances that the load will be less than the what we calculated. So either the load fails, material does not fail, or material fails, load does not fail, or both fails. This will be the probability, and this will be 0.0975. This will be 0.0975. Give me yes or no. Everyone on the comment section. Everyone, guys. Come on, come on, come on, everyone. Give me yes or no. Everyone got it? Okay. Now, M25 concrete with creep coefficient 1.5, what will be the long-term static modulus of elasticity as per the code? Long-term static modulus of elasticity is given by 5000 under root FCK upon 1 plus theta. So what is FCK? The characteristic strength, that is root 25, it will be 5 upon 1 plus 1.5. So it is 5000 into 5, 25,000 upon 2.5. This value will be 10,000. This value will be 10,000. Give me yes or no. Give me yes or no, guys. Come on, come on, come on. Any doubt? Yes, Vinay. Good. Good, good, good. This homework. Now do this. What is the effective width of the flange? BF. What is the effective width of the flange? First of all, why we find the effective value here? What is the need of finding the effective value? Can anyone tell me? You might be knowing the formula, but I am asking why to find out the effective value BF. If the width is 1000 here, why we can't take 1000? Why we can't take 1000 here? What is the difficulty in that? What is the difficulty in 1000? Because guys, we are here now, the stress variations is something like different at every point. So instead of that, we make a effective width where we can take a constant stress. Instead of that, we take a constant width where we can take a constant stress, because we assume in our RCC that along the width stress is same, but here the stress is varying. So we take that width for where we can take the as constant stress, and then we can do the calculation. So BF is given by, for a isolated T-beam, the BF value is different for different cases. For isolated T-beam, it is L0 into L0 by B plus 4 plus width of the web. So what is L0? 6 meter, that is 6000 mm upon 6000 by B. Width here is 1000 plus 4 plus width of web. Width of web is 300. If you solve this, it will be 900 mm. If you solve this, it will be 900 mm. Have you got it? Please tell me. Yes. Okay, this is a pre-stress. Pre-stress we can take in a different session. Yeah, do this MSQ. Or before that, do this one. Percentage of steel for the design of a singly reinforced section by limit state depends on what factors? The percentage of steel for the balanced section, percentage of steel for the balanced section, I am not going into the derivation of complete that similar triangle and all. The final value I am writing 41.61 FCK by Fy XU limiting by D. This is the percentage of balanced section. So it is depending on characteristics. See, FCK is coming, Fy is coming, ES is not coming here. Geometry of the section, yes, the D is coming. So it is AB de Villiers. It is AB de Villiers. Got it? Got it? Any doubt? Okay. Now this MSQ. Which of the following statements are correct for the beam shown in the figure, which is subjected to a factored shear force of 190 kilonewton? Factored shear force of 190 kilonewton, use M20 concrete and Fe415 steel. M20 concrete and Fe415 steel. First of all, let us see what, without reinforcement, how much the concrete itself can resist. Okay, so AST you can calculate 3 into pi by 4 into 20 square. This is 942.48. So percentage of steel, if you calculate percentage AST, it is AST upon total dimension, and this value you will be getting here as 0.73%. And for 0.73%, what is tau C? 0.56. So tau C is equal to 0.56. Tau C is that thing which can be resisted without reinforcement. Tau C is that stress which can be resisted by concrete itself. So what is the force? What is the force? This is the stress, na? So it is stress into area. So it is 0.56 into 275 into 470. Okay. 0.56 into 275 into 470. What is this value coming? 72.38. But what is actually coming? Actually coming is this VU. So for how much we have to design? How much we have to design? How much we have to design? This is coming shear force, and 72.38 can be resisted by concrete itself. So this is 117.62. So we have to design for 117.62. Because out of this much 190 na, 72 is itself resisted by concrete. So we have to design for 117. So nominal shear force is the case. This is the case when the value resisted by concrete is more than what is coming. So then minimum reinforcement is required. When the shear resisted by concrete is more than what it is coming. So no need of reinforcement, but we provide the minimum reinforcement. So this is not the case. Now what is the spacing of two-legged 8 mm stirrups? So you can apply the formula of stirrups now, the spacing. So ASV is equal to area, what is the stirrups? 2 leg na, so it is 2 pi 4 into 8 square, it is 100.53, and spacing is given by 0.87 Fy ASV into D upon VUS. If you put all the values na, it will be 145 mm. But actually VUS is minimum of this. We have to take three criteria na. 0.75 D if you calculate, it will be 352. Okay, then it is 145 mm as computed here. So one criteria minimum of value will be taking, and third the formula that 0.875 FISB upon 0.4 BW na, from there it will be coming as 330. So minimum value is coming 145. Okay, so the nearest answer is this. So answer will be A comma C. Answer will be A comma C. Give me yes or no. Have you understood? Have you understood? Everyone? Now many students I guess have joined us late. So let me tell you, lot of numericals we have done. Pre-stress we will be taking in some different session. Okay, those who have joined late, you can see these questions again. It will be helping you guys for a quick brush up. For a quick brush up. A and C are correct. Yes, Arvind. Good. Good. Okay, so you can download the Resultant Civil app from the Play Store. In the Play Store, you can write Resultant Civil, download the app, and you can also follow us on Facebook and Instagram. Okay, for 2025 students, you can join the crash course. Okay, for any detail, you can connect me in these numbers. Directly, I will be taking these calls. For GATE 2026 and GATE 2027 students, we have the complete course where live plus recorded classes will be there. For every subject, we'll be giving you PYQ. For every subject, we'll be giving you study notes. For every subject, we'll be giving you workbook. For every subject, we'll be giving formula book, which you can download for lifetime. Okay. So for 26 and 27 students, you can join our full batch where live and recording classes are going on. Okay. I hope you enjoyed the session. For any doubt, please let me know in the comment section. Thank you. Thank you all guys. Take care. Thank you. Thank you everyone.